Now let me show you a project in the Python language. We are going to do one project, one simple project in the Python language using the decision tree model. So in the very first step, we will import all the respective libraries. Import pandas as PD, and then from scikit-learn.tree import decision tree classifier. From scikit-learn.model selection import train test split. From scikit-learn.matrix import accuracy score. So these are the libraries that we have imported in the Python language for this decision tree model. First we have imported pandas. We know that what is pandas? Pandas stands for the Python data analysis. It is used to read the data file. It is a very important library of the Python language, which is very helpful in the machine learning. So its short form is PD. It is just a short form. It can be any name. It can be P, it can be D, it can be A. It is just the short form of the pandas. So for the pandas, you have to use PD all the way in the project. Instead of writing the pandas, you have to use PD. And then we have used the scikit-learn. From the scikit-learn, we take tree, dot tree. From the tree, we imported decision tree classifier. Decision tree is the classifier for this model. And then again from the scikit-learn, we take model selection. From the model selection, we have imported train test split, which is used for splitting of training and testing data sets. And then again from the scikit-learn, we check matrix. From the matrix, we have imported the accuracy score. So look at here, we know that what is matrix? Matrix is the sub-library of the scikit-learn, where it goes the confusion matrix, it goes the classification report, it goes the accuracy score, precision rate, precision score, and all of these outputs are covered by the matrix. It is the submodel or sub-library of the scikit-learn. So we are using two main libraries here in this project, pandas and scikit-learn. Look, sklearn means scikit-learn. It stands for scikit-learn. Step number 2. In step number 2, we are going to load and read the data. So with this one line of code, d equals to pd.read csv of books.csv, we will read the data. For this data, I simply give the name d. So this d represents this whole thing with this one line of code with the help of the pandas. The short form of the pandas is pd, so you have to use pd instead of pandas. So pd.read csv. Read csv is a function where we can read the csv file. What is the name of the CSV file? The name of the CSV file is books.csv. It is the file name. If it is something else, you have to put that name. But since the name of that CSV file is books, therefore you have to put books.csv. So in step number 2, we read the CSV file. Now to explore the data, we read the data. Now to explore the data, that what is inside that CSV file, how the data looks like internally. Let me take the printf d. When you take the printf d, you will get this output. This is the internal look of the data. Here we have age, we have gender, and then we have books. Look, these are the books names. We have love story books, we have business books, we have politics, we have history books, we have geography, again we have politics. So the male is represented by the 1. From here up to here is the male, and the female is represented with the 0 from here up to here. So 0 is for the female and 1 is for the male. This is the age range from 18 up to 45. And these are the index numbers. Remember, index numbers, positive indexing starts from 0, 0, 1, 2, 3, 4, 5, and so on. This is how this data looks like internally. Now what this decision tree classifier does, it will classify the respective data into its own class, and it will show us that whether it belongs to the love story books or business books or politics books or history books or geography books. Let's move ahead. Inputs of the data. What are the inputs of the data? Let me first determine the inputs of the data. So we have x equals to d dot drop of columns equals to books. Look, we are talking about the inputs of the data. With this one line of code, we will drop the columns of the books. What is books? Books is actually the target class. This is the output class. Look, these two columns represent the input data. This is my input data, these two columns. This column is the target class. This is the output data. So books is the output data. To determine the inputs of the data, we have to drop the columns of books, because books is the data of the output. we have to use D. What is D? Don't forget it. This data is represented now by the D. So the data that we have read, is now represented by the D. So you have to use D all the way. Therefore, we have used D.drop, which means from the data D, drop the books columns. You have to put the close bracket and then books inside the quotes. And then with the help of this one line of code, it will drop the books column. So the rest of the two columns will be my input data. So look, when you drop the column of books, which is the output data, we will left only with these two columns, which is the input data. So we will left with the input data. Because remember, when you take the print of X, you will get this output. If you want to know the X, you just take the print of X. When you take its print, run the program, you will get this output. So look at here, we have only two columns, the age column and the gender column. This is my input data. The output data has been dropped, which is the books column, with the help of this drop function. Now to determine the outputs of the data, we have determined the input of the data, and then we need to determine the outputs of the data. So we can write y equals to D of books. Look, the data that we have read is represented with a D. So you have to put a D with the close brackets and then books within the quotes. It will represent the output class. Remember, the column of the books was the output data. Here, this books is the column which is the output data. But if you want to know, you have to take the print of y. When you take the print of y, you will get this output. So my y is this column. This books is the output data. This is the column of the output data. So y is my output data and x is my input data. We have determined the x and y variables, x for the input and y for the output. Now in step number 3, we will do the cleaning process. Clean the data, but make sure data is already cleaned. We don't need the cleaning process. Look, this is the complete internal form of the CSV file. So it is my whole data. It is my whole data in the CSV file. When you look to this data, there is no single missing parameter and there is no term with the duplicates. Therefore, we don't need the cleaning process because the data is already cleaned. Go for the fourth step. In the fourth step, do split of the data in train, test. Split the data in train, test, sets. Do the splitting process. So with this one line of codes, we have x train, x test, y train, y test equals to train test split of x, y, test size equals to 0.2. Look at here, this one line of code, we have splitted the data into train, test, sets. For the train, we have x train and y train, x test and y test. So this is the input train data, this is the output train data. This is the input test data, this is the output test data. So x is the input data, y is the output data. And then we use the train test split function, where we are passing the input data and the output data. Make sure for splitting the data, you have to pass the input data and the output data. In step number 2, we had x, it is input data. This is y, which is the output data. So simply plug in x, y, which is the input data and the output data, with the test size 0.2, which means 2%, which means 20%. 0.2 is the 20%. The test size is 20% and the training size of the data is 80%. So we have allocated 20% for the test and 80% for the training. Create the machine model. Create that decision tree machine model in step number 5. So with this one line of code, model equals to decision tree classifier, we have created the model. The name of this model is model, M-O-D-E-L. I gave the name model here. And then in step number 6, we need to train the machine model. We have created the model. Now the next step is to train the model. To train the model, I'm going to use the fit method. So model.fit of x train, y train. Look, for the training, I will pick only x train and y train. So I will only pick the training data. It is 80%. I'm not interrupting the x test data and the y test data. The test data is 20%. So I will keep this 20% safe on one side. Later, for the prediction, for the output, I will pick the test data and will test the model. That what is the prediction of the model? What is the performance of the model? What is the stability of the model? Test data will use later for the testing. It will not be used for the training. For the training, we have only X train, Y train, which is 80% data. Fit method is used to train the model. And then in step number 7, do the prediction of the model. We have created the model, we have trained the model. Now the next phase is to do some kind of prediction. I want to check some kind of output of this machine model. What will be the prediction of this model? What is the output of the model? So I can write prediction equals to model.predict of X test. Look, as I told you, that test data will later used to test the model, to do some kind of prediction of the model, to get some kind of output of the model. So there we have used X test data. I'm first picking only X test data, not Y test data, the input test data. So I want to do the prediction. What kind of prediction I will have? Look, when you take the print of prediction, you will get the output. You will get the output that what kind of prediction I have in the X test data. You will only get the X test data and the output if you take the print of prediction. So in step number 7, we did the prediction of the model. Now you might be confused that why I need step number 7 if we have step number 8. Step number 8 is the final evaluation of the model. But why we need step number 7? Look, sometimes you need to check the model, to get some kind of output of the model before to go for the final stage, before to go for the final evaluation. You want to check some prediction. You need some kind of output. Therefore, in step number C, you can check the model. You can simply take some kind of prediction from the model before to go for the final stage, which is the final evaluation of the model. So when you take the print of prediction, you will get the output of this prediction. You simply take the print of prediction, you will get the output. Now the final step is step number 8, final evaluation of the machine model. This will be the final step. In this final step, look at here, in the final step, we want to check the accuracy rate, we want to check the precision rate, we're going to check the confusion matrix. So in this case, I just want to check the accuracy score. What is the accuracy score? So score equals to accuracy score of Y test, prediction. Look, again, I'm using test data here, test data. As I told you, the test data is used for the final prediction, for the final output of the machine model once you trained it. So in prediction, we have the X test. Therefore, I put prediction instead of this whole thing, instead of X test, instead of this whole thing, I simply put the variable prediction, which is actually the X test. It is actually the X test and then the Y test. So I have given both the Y test data and X test data to check the accuracy score. So when you take the print of score, you will get this output, which is 1.0. 1.0 means 100%. So the accuracy rate, the accuracy score for this decision tree model, for this respective decision tree model is 100%, which means that it is in a very good condition. It is in a very good situation. It is a very stable model. It gives 100% accuracy score rate. Now run it one more time. When you run it one more time, just press Ctrl plus Enter. If you want to use the Colab, if you are doing this coding in the Colab, just simply press Ctrl plus Enter. It will run one more time. So when you run it one more time, you may get 0.75, which means 75%. And then when you run it one more time, by pressing Ctrl plus Enter, you will get something else. It may be 80%, it may be 90%, it may be less than 75%. It just swings around 100%, like 90%, 95%, 80%, 85%, 70%. This model is in a very good condition, in a very good situation. Because remember, we have 80% training data. We have 20% testing data. But let me check if you want to change the size of the test data. Let me just change the size of the test data. If you remember, last time we had 20%, this time I have 0.8, which means that 80%. Now in this model, I have 80% test data and only 20% training data. So make sure for the training you have to keep more data. For the test size you have to keep less data. Last time we had 20% test data and 80% training data. Now I'm taking 80% test data and 20%, only 20% for the training data. Run this whole model once again with the similar steps and then check the score, accuracy score. When you take the printf score, simply take the printf score, you will get the output 0.4, which means that 40%, the accuracy rate dropped from 100% up to 40% if you change the size of test from 20% up to 80%. Now look at here, the machine is not in a stable position. This decision tree machine model is not in a good condition because remember, we have allocated very less data for the training. We trained this model with a very less data, only 20%. So it is not enough. It is not enough for a model to be trained. Therefore, the accuracy score that we got is only 40%, which means that this decision tree model is very bad compared to the previous one. If you run it one more time by pressing Ctrl plus Enter, you may get only 20%, or you may get only 30%, or you may get only 40%, or you may get only less than 20%. So by running the model again and again, you may get different values. It will just swing between 40, 30, 20, 25, which is not good for the model. Look, this is the complete codes. This is the complete codes for this decision tree machine model. In the first step, we have imported the libraries. We have imported pandas and then scikit-learn. In the second step, we read the CSV file with the name books, and then we identify the X value by dropping the Y column, and then we determine the Y value with the books, which is Y. And then we did the splitting of train and test data. And then we created the model. Then we trained the model with the fit function, with the fit method, and then we did some kind of prediction. And then we checked the accuracy score. With 20% test data and 80% training data, we got 100% accuracy. But with 80% test data and 20% training data, we got 40% accuracy. So when you compare this model with the previous one, so there is a similarity. We have the same steps. We have the same steps with a slight difference here. We are determining the X and Y values. Because we have CSV file, it is not a built-in data, remember. It is not a built-in data. Therefore, you need to determine the X values and the Y values. So we saw that all the classifiers of the machine model have the same process. They have the same steps. So I hope you understand the basic and the fundamental of the machine learning. Now I will check that how this decision tree classifier do classification based on the given data. So I just want to check some output here. I will try to classify the data into its own respective class. So to do so, what I'm going to do, I will simply pick X value and the Y values with a fit method. So simply put model.fit of X, Y. Look, I'm not taking the X train and Y train data. The model has been trained. It has been already trained. I just want to try some kind of out by giving the X and Y data. So I'm fitting X and Y data in the model.fit of X, Y. What is X? X is the input data and Y is the output data. Just fit X, Y here with the model. And then do the prediction here. Prediction equals to model.predict of 25, 1, 20, 0. Look, I just randomly passed the data, which is actually the test data. I'm just randomly passing this data. I want some kind of prediction here. To do so, use the same line of code. Prediction equals to model.predict of 25, 1, 20, 0. Now look at here. 25 is the age. 1 is for the man. 20 is the age. 0 is for the female. So when you take a print of prediction, you'll get this kind of output in the array form. For 25, 1, we have business category. For 20, 0, we have history category. These are the target classes, target categories. So we have categorized this data into business and this one into history. Look, 25 with the 1. So we are giving the number of the age, which has not been mentioned here in the list. We have 18, 19, 20, 27, 29, but we don't have 25. So from 18 up to 20, we have the books for the love story. The person with the age range from 18 up to 20 tries to read the love story books. And then onward this, they are trying to study business, which means that up to 20 we have the love story category of the books, which is the target class. This is the output. And then onward this, like 21, 22, 23, 24, 25, up to the 31, we have the business class. So for 25 with the gender 1, remember this 1 represents the male. This 0 represents the female. So 25 with the gender 1 comes inside the business class. Similarly, what about the 20? 20 with a 0. For the 0 we have 17, 19, 21, 26, but we don't have 20. 20 is missing. So we can categorize that new data into their own respective classes. Where 20 comes? 20 comes after 19, we have 20 and then 21. So 20 with a 0 comes with the history category. Therefore, the data 25, 1 has been classified with the business class, with the business category, and 20, 0 has been classified with the history category. Remember, 25 and 28 is not there in the list, but it comes within the range. When we checked 25, which is actually not in the list, but the machine decides that 25 comes within that specific range. So it has been classified with the business target class. Similarly, 20 is not mentioned there in the list with a 0. Remember, 0 is for the female, 1 is for the male. It classified this 20, 0 with the history category. So there we got the successful prediction. We got the output, we got the accurate output. So it means that the model is in a very good condition if we have 20% test size and 80% training data. We tried the new data here, which is not in the list, but based on its range, it has been classified into its own category, and this has been classified into its own category. And this with the business and this with the history.